In this video, I want to talk about medians, and I'm going to start by defining a trapezoid. A trapezoid is a quadrilateral having two opposite sides parallel. So of my four sides, at least two of them need to be parallel, and then the other sides will connect those parallel segments, such as this. My parallel sides are called my base, or my bases, and the other sides are called the legs. If the legs are congruent, then this is called an isosceles trapezoid. The other thing I want to define is the median. So the median is this line segment that joins the midpoints of the legs. So these two segments would be congruent and these two segments would be congruent, and this would be the median, the one that joins the two midpoints of the legs. Another special type of quadrilateral is a parallelogram. This is a quadrilateral with both pairs of opposite sides parallel. So here is an example. Went over just a little too much on this leg, but these two segments should be parallel and these two here are parallel. A parallelogram whose angles are right angles is a rectangle, and a parallelogram is going to be a special kind of trapezoid. The first thing I want to prove, the midpoint of the hypotenuse of a right triangle is equidistant from the three vertices. So let's suppose I have a right triangle, something like this, where this is my right angle. We'll call this A, B, and C. We're going to take the midpoint of the hypotenuse, we'll call it M, and draw the segment CM. So what I'm claiming is A to M is congruent to the segment MB, which is also congruent to CM. We already know AM is equal to MB. This comes from the definition of the midpoint. Since M is the midpoint of segment AB, it is halfway between A and B. That tells us that the distance from A to M is equal to the distance from M to B. I'm going to call this angle here 1 and this angle here 2. Let's suppose segment CM is bigger than segment AM. So we want to show they're the same. Let's start by supposing it's bigger. Then I know the measure of angle A is greater than the measure of angle 1. Since CM is a longer side, it's going to correspond to a larger angle by our scaling inequality. Same thing in this smaller second triangle down here. The measure of angle B will be greater than the measure of angle 2 because CM is a longer side, so it needs to correspond to a bigger angle by the scaling inequality. If I try to then add these, I have the measure of angle A plus the measure of angle B needs to be greater than the measure of angle 1 plus the measure of angle 2, which we know is 90 degrees. So we need that the angle A plus the angle B is greater than 90 degrees. However, that gives me a contradiction, since that would mean that this triangle sums to something larger than 180. We can do something similar if we suppose CM is smaller than AM, then we can get that this triangle would sum to be smaller than 180, which is not what we want either. So therefore, it has to be the same distance. It has to be equal. Since it can't be greater than or less than, they have to be equal. We also have the converse of this. So let's suppose we have a triangle. This time I'm not going to draw it as a right triangle, but we'll prove that it does have to be one. We're going to once again let M be the midpoint of side AB. And we're going to suppose that the distance from C to M is the same. So we're going to suppose the distance from M to each of the vertices is the same. Then this must be a right triangle. So once again, I'm going to call this angle 1 and angle 2. We then have the measure of angle ACB. has to be equal to the measure of angle 1 plus the measure of angle 2. Since this up here is an isosceles triangle, we know that angle 1 has to be congruent to angle A by our isosceles triangle theorem. Similarly, this triangle down here is an isosceles, so angle 2 has to be the same as the measure of angle B, once again by our isosceles triangle theorem. I'm then going to rewrite this as 1/2 times 2 times the measure of angle A plus 2 times the measure of angle B. So this may seem like a strange way to do it, but you'll notice it is equivalent to just saying angle A plus angle B. I'm then going to write it. I'm going to rewrite this as angle A plus angle B plus angle 1 plus angle 2. And this comes from the fact that angle A and angle 1 are the same, and angle B and angle 2 are the same, so I just rewrote how I'm referring to this to angle A and to angle B. Well, this is 1/2 the measure of A plus the measure of B plus the measure of C, my actual angle sum that I want. Angle A plus angle B plus angle C, that is 180. So this would be 90. The measure of angle ACB is 90, so this would be a right triangle.